This is the video for the Algebra 1 test on Exponents, the study guide. One of the things to remember when talking about exponents in general is that they follow different rules. They tend to be slightly different. They don't follow the same rules as coefficients do, as fractions do, as the numbers on front do. They tend to be slightly behind is what I tend to like to talk about. Remember that when you multiply, exponents are just adding. When you're dividing, exponents are just subtracting. When you're doing a power to a power, they're finally up to multiplying. Anything to the power of 0 is always 1, and negative exponents shift to the opposite side of a fraction bar. So it's negative in the bottom, moves to the top, and now it's positive. If it's negative in the top, it shifts to the bottom, and now it is positive. So it's negative at the top. So wherever it is, if it's negative and you don't want it to be negative anymore, which we don't want because they should all have positive exponents, they should move to the opposite side of the fraction bar, from the top to the bottom, bottom to the top, and when they move, they now become positive. That's the point of moving them, so that they are now positive. Let's simplify some of these. 8 to the third times 8 to the 11th is not 64. We keep the same base. 8 to the third times 8 to the 11th is 8 to the 14th. Please do not make this 64 to the 14th. It's only 14 eighths. There are 3 eighths and 11 eighths. If you put 64 to the 14th, that means there are 14 64s. There are 14 eighths. Number 2, very similar. Let's combine these. 4 to the second times 4 to the 5th is 4 to the 7th. And then another 4 fours is 4 to the 11th over 4 to the 3rd. Now, we could subtract, use the subtraction property. 11 minus 3 is 4 to the 8th. The way I like to think of it, though, is to say 4 to the 11th over 4 to the 3rd. They're going to cancel each other out. Are there more 4s on top or bottom? More 4s on top by 8. Either way, it's 4 to the 8th power, so it is not 48. Number 3. One of the strong things to keep in mind is that coefficients behave normally. What we don't do in this scenario is we don't say, oh, let me subtract that and make it 12. If you subtract it, you're not doing it correctly. Those are exponents. We can simplify the numerator, the numerator and the denominator as coefficients. 15 over 3 is a 5 in the numerator. All right, x to the 5th has nothing to cancel this. It stays as the numerator is x to the 5th. Remember that 5 and x to the 5th, while they're connected by multiplication, they each have their own exponent. This has an exponent of 1. They're independent. Let's not forget that. That'll come up later. Y to the 7th over y to the 2nd. Are there more y's on top or bottom? There are more y's on top by 5. You can also do 7 minus 2 is 5. Now I made this fraction bar being conservative, but we will not need it because there are no other numbers in the denominator. We could put a 1, but that's all I need. For number 4. There's no powers on the outside, so I'm going to follow order of operations. Nothing to do inside, nothing to do inside. I'm simply multiplying these two. I don't even really need the parentheses, a squared b to the 4th. A squared times a, sorry, this is cubed. A cubed times a squared is a to the 5th. And b times b to the 4th is b to the 5th. Remember, when you're multiplying, you're adding. Moving down to number 5. For some reason, this question, I'm going to cross out the 5 so you can see it. For some reason, this question really gives students problems. It's actually a very easy question. It gives them problems. They try to make this x to the 27th, but it's not because this is in the bottom, this is in the top. Several ways to handle this. What I would suggest doing is just make them both into fractions and multiply straight across. 1 times x to the 25th is x to the 25th. X squared times 1 is x squared. As we talked about, are there more x's in top or bottom? Top by 23. You could also do 25 minus 2 is 23. Another way you could have thought about this is 1 over x to the 2nd, we know that's x to the negative 2. Now it's in the top and it's negative, times x to the positive 25. And you can still, when you're multiplying, add exponents. 2 negative 25 positives is x to the positive 23. In either event, it's still the same thing. There are several ways often to do these problems. Number 6. There's nothing to do inside, but there is an exponent on the outside. So for lack of a better way of saying, it's not actually, but it's like the distributive property. So there's 2 of these, 2 of those, and so forth. So p to the 5th to the 2nd becomes p to the 10th. K to the 2nd to the 2nd becomes k to the 4th. That's multiplication, not addition. And a lot of students will just do this, and that's incorrect, because they forget that the 3, the negative 3, also has its own exponent to the first power. So 1 times 2 is negative 3 to the 2nd power. I would put this in parentheses because it's not only asking for 2 3s, it's also asking for 2 negatives. If you don't put it in parentheses, that would be wrong because this is 2 3s and only 1 negative. But by putting it in parentheses, now it knows I want 2 negatives also. You could make this positive 9k to the 4th p to the 10th. But if you were to make it negative 9, that would be incorrect. So either one of these would probably be acceptable. We probably lean towards the bottom one, but the top one, I think that we would also accept. Let's do number 7. Nothing to do inside these parentheses, it's 2y squared. But inside here, well, there's nothing to do, there's the power to a power. So 5 to the 3rd is y to the 15th. But don't forget, once again, we got to do negative 3 to the 3rd power in parentheses once again. So we can drop these parentheses, 2y squared, negative 3 to the 3rd power is negative times negative times negative, which is negative 27y to the 15th. 2, negative 27. We can multiply these. I know they're not the same base, and so we treat them that way. Negative 54. Y to the 2nd times y to the 15th is y to the 17th. When you're multiplying, you finally add. Y to the 2nd times y to the 15th, you add the extra. These are regular coefficients, so I treat them like regular numbers. Regular numbers, the rules still apply. Exponents follow different rules. 8. Now 8 is a great question because there's a lot of ways that you can do this. You can quote unquote distribute the negative first. Again, it's not. You can clean up the inside by moving the n down. And either one will give you the right answer. Let me show you what I'm saying. If I want to quote unquote distribute the negative 2, this is m to the negative 14. N to the now positive 6 is negative times negative is a positive. And p to the negative 4. Now, when we have negative exponents, we know they've moved. Negative moves across the fraction bar. M to the 6 stays, that's positive, but m to the 14th now moves to the bottom. And this p to the negative 4, which is in the bottom, can move up to the top, make it p to the 4th. So it's n to the 6th, p to the 4th over m to the 14th. The other way what I'll say you could have done is you could have moved this down from the start, n to the 7th over n cubed p squared, all to the negative 2, which would be m to the negative 14 over n to the negative 6, p to the negative 4, because everything gets multiplied by 2. And then when I switch it, everything just switches. The m to the 14 moves to the bottom. These two move to the top, and when they move, they become positive. Either way, you get the same answer. Number 9, great question. We could do everything to the power of 0. So 4 times 0 is x to the 0. Y 10 is y to the 0. Negative 7 times 0 is z to the 0. Over, don't forget the 6 goes to the 0 power also. Times x to the 14 times 0 is 0. Now anything to the power of 0 is 1, times anything to the power of 0 is 1, times anything to the power of 0 is 1. All over 1 times 1, which is 1 times 1 times 1 is 1 over 1 times 1 is 1, which is 1. Or what you probably should have done was literally anything to the power of 0 is 1. Number 10, remember that if it's negative, it moves to the top. So I can move it right now, or I can, for lack of a better way, distribute it. 1 stays in the top, and it's 5 to the negative 3, 8 to the negative 3. Since they're negative, they move to the top. 5 to the 3rd, 8 to the 3rd, and 1's on the bottom, where you just save this. Technically, you could do this, as long as you don't have negative exponents. Number 11, same idea. For lack of a better way, we'll quote-unquote distribute. So y, negative 3 times negative 2 is positive 6. X, 4 times negative 2 is negative 8. And don't forget the 4 gets a negative 2 also. Students often forget the negatives. We're not done because we have negative exponents. Y to the 6 stays. You might say at this point, what do you mean move to the fraction bar? There was no fraction bar here. In this case, there was no fraction bar. Well, you can imply that it's all over 1. Since it's all over 1, then we can move stuff from where it used to be. So I'll move it. This stays at the top. This now moves to the bottom. And this 4 squared, or 16, moves to the bottom. It's y to the 6 over 4 squared x to the 8. And I have to move this so we can see number 12, the long one. All right, in the numerator. No quote-unquote distributive property power to a power. So let me just multiply my coefficients. 12 times 2, that's 24. a to the fourth times a, that's a to the fifth. B cubed times b to the seventh is b to the 10th. And c to the negative fifth times c to the second they add is c to the negative 3, which means eventually it's going to move down. Bottom is still 32, a to the 7th, b to the negative 2, c. I don't like dealing with things while they're negative, so I'm going to move it. 24, a to the 5th, b to the 10th. Now this b moves up, becomes positive, positive b squared. Over 32, a to the 7th. This c is still here, and this c moves down, c cubed. 32. I just see those coefficients as different, so I'm going to simplify that very shortly. A to the 5th over a to the 7th, which I'll deal with this right now. Are there more a's on top or bottom? There are more a's on bottom by 2. I'll make that a 2, and these are gone. B to the 10th times b to the 2nd is b to the 12th, and c times c to the 3rd is c to the 4th. We're almost done, except 24 over 32 simplifies. Well, 8 goes into both of those. 8 goes into 24 3 times, 8 goes into 34 4 times. So again, 8 is what simplifies this. So 8 goes into 24 3 times, and 8 goes into 32 4 times. Is my fully simplified form. Number 13. There are some tricks in this one, but let's do sort of order of operations. Got to work inside. I have nothing to do here, but there's the exponent. Nothing to do, but there's an exponent. Nothing to do, but there's an exponent. Let's do with the exponents first. X to the 3rd to the 2nd is x to the 6th, but don't forget 3 squared also gets 1. Anything to the power of 0 is 1, so that just sort of goes away. Don't even have to deal with that anymore. The denominator, don't forget 6 goes to the 2nd power also. X to the 6th, 3 to the 2nd is 6, and y to the 14th. All right. The same amount of x's in top and bottom, so they fully cancel each other out. 3 squared, you could do it this way. 3 squared is 9, and 6 squared is 36. That obviously simplifies to 1/4, and then there are still y's in the bottom, y to the 14th. So 1 over 4y to the 14th. Do you need the 1? Yes, you do. Yes, you do need that 1. Running a little bit out of space. So let me pause this real quick. Now we have a bit more space for number 14. It's all the second power, so I'm going to quote unquote distribute 4 to the second power. Again, the 4 gets the second power also. Add to the negative 4. Well, h to the 0 to the second power is still 8 to the 0, which is going to be 1. We'll deal with that in a second. J to the 8. All over 8 to the second power. F to the 6th power. H to the 8th power, j to the 2nd power. 4 to the 2nd power is 16. 8 to the 2nd power is 64. That's going to simplify to 1/4, which will come back in just a second. This negative f moves to the bottom. This positive f stays in the bottom. Stays in the bottom because it's positive. So now this is at the bottom, and now it's positive. H to the 0, that goes away. I have j to the 8th, and I have an h to the 8th down here, and then j to the 2nd power. All right, let's simplify a little bit. Remember that coefficients behave normally. You don't subtract that. 16 over 64 simplifies to 1/4. Are there more j's on top or bottom? More on top by 6. This is j to the 6th. F to the 6th times f to the 4th is f to the 10th. We have an h to the 8th right here. You don't necessarily need the 1, so you could just do this, but if you put a 1, that's okay also. It's j to the 6th over 4, f to the 10th, h to the 8th. Number 15, you could rearrange this and move it up, and then quote-unquote distribute, or you can quote-unquote distribute, and then go from there. I'm going to quote-unquote distribute first. 3 to the negative 2, x to the negative 4, over y to the positive 6 now. Is that positive? That means it stays. What's going to happen is, since this is negative, it will move to the bottom, and now it's positive. This will also move to the bottom, and now it's positive. And a 1 remains on top. So to clean it up a little bit, it's 3 squared, or 9, x to the 4th, y to the 6th, 1 over that denominator. And number 16, we have a negative exponent, so I'm going to quote-unquote distribute. Negative 2, don't forget in parentheses, the negative 3rd power. n to the negative 6, m to the negative third times 12m squared n. I could move these, but let me try to add them and clean them up first. First of all, negative 2 to the third power is 3 negative 2's, which is positive 4 times negative 2, which is negative 8. It's negative 8. All right, n to the 6 times a positive n is n to the negative 5. M to the negative 3 times m to the second is m to the negative 1. And don't forget we have this 12 still. I'm sorry, I messed this one up. This part's messed up because it's still, I'm going to come back to this guy. I'll do it over here. Messed that up. Was a little hasty with my 3. Negative 2 to the negative third is 1 over negative 2 to the positive third. The negative exponent does make things negative, moves to the bottom, so now it's to the bottom. Now, negative 2 to the third is still a negative 2 times a negative 2 times a negative 2, which is 1 over a negative 8. So this is negative 1/8. Or 1 over negative 8. 1 over negative 8. Continuing to move stuff around, since this is negative, exponent moves to the bottom. Since this is negative, it moves to the bottom. Now it's a positive 1. There's 12 up top. Some more simplifying. 12 over 8 simplifies to 4 goes to both of those. 4 goes to 12 3 times. 4 goes to 8 2 times. Don't forget the negative out front, which side and front could be the same thing. And let me alphabetize this m n to the 5th. N is to the 5th power, but m and n are not to the 5th power. It's negative 3 over 2mn to the 5th. Some final points I do want to make. If you have something like this, 1 over 2w to the negative 2, something has to move because of the negative exponent, but not both of these are moving. A lot of students will put the whole thing in the top because they think this has a negative exponent also. Remember, that has a positive exponent, so it's not moving. The 2 is actually staying. The only thing that has the negative exponent is this guy. So this becomes w squared over there. Remember, when you have something like this, 1 over 2w to the negative 2, or to the negative 3, whatever, the only thing that has a negative exponent is that base directly to the left of it. There's also a difference between this and this. This is 2 negative 3's, which is negative 3 times negative 3, which is a positive 9. This is 3 squared, which is 3 times 3. And oh yeah, by the way, bring down your negatives. This is negative 9. So these are not the same thing. Make sure you pay attention to that. And lastly, it's important for you to know that if you have like a negative x to the 5th, all the way to the 4th power, this will be a positive x to the 4th over 5 to the 4th. Why positive? Because if I have an even amount of negatives, it'll be positive. But if this instead were negative x to the 5th, all raised to the 5th power, this would be a negative x to the 5th, 5 to the 5th, because since there's an odd number of negatives, that means my whole value is negative. Keep that in mind. Even negatives, positive, odd negatives is negative.